I am Gan Wing, and I will present a question 2, deadlock banker algorithm, question A and B. So let's look at the question. Consider a system with 4 processors, which is P0, P1, P2, and P3. 3 resource type, which is A, B, and C. Resource type A have 12 instances. Resource type B have 8 instances. Resource type C have 9 instances. This is allocation table, and this is max table. Draw a resource allocation graph. This is resource allocation graph. How to draw it? Let's look at next slide. This rectangle means the resource type with A, B, and C, and this dot means the instances. This circle means the processors P0, P1, P2, and P3. So let's look at P0. P0 have 2 instances of A. So we draw 2 arrows from A to the P0. And B have 1. So we draw 1. C have 3. So we draw 3 arrows. And P1 have 3 instances of A. So we draw 3 arrows. B have 2. C have 2 also. And the P2 have 4 instances of A. So we draw 4. And B have 0, so we don't want to draw. And C have 2. And the last processors, P3, have 1 instances of A, 1 instances of B, and 0 instances of C. So this is our resource allocation graph. Move on, question B. Is the system safe? Use banker algorithm to prove it. So we want 4 tables in this question. Allocation table, max table, need table, and available table. The allocation table and max table is already provided in question. So we want to calculate the need table and available table. The formula get need is max minus allocation. So we look P0A, max is 8. The allocation is 2. So 8 minus 2 is 6. And B, 4 minus 1 is 3. And 5 minus 3 is 2. So move on P1. The P1 resource type A max is 5. The allocation is 3. 5 minus 3 is 2. And 3 minus 2 is 1. 3 minus 2, 1 also. Move on processors 2. The 4 minus 4 is 0. 5 minus 0 is 5. 4 minus 2 is 2. And P3, the max resource type A is 3. 3 minus 1, 2. 3 minus 1, also 2. 2 minus 0, also 2. So this is our need table. Now move on this slide. We want to calculate the available table. So formula get available instances is total instances in the system minus total allocated instance to all process. So the total instance A is 12 instances. So 12 minus the all allocated instances. So 12 minus 2 minus 3 minus 4 minus 1 is 2. The total instances in B is 8 instances. So 8 minus 1 minus 2 minus 0 minus 1 is 4. And C have 9 instances. So we minus 3 minus 2 minus 2 minus 0. So the number is 2. This is our available table. So for next slide. In this slide, we want to use safety algorithm. Want to make sure the need is less than or equals to available. So this P0 need is 632. And our available is 242. So the 6 is less than 2. So this is a false. And now we move on P1. P1. The need P1 is 211. And 2 is equals to 2. 1 is less than 4. 1 is less than 2. So this is true. When true, we want to update our available. How to update our available is add the allocation. So we add the allocation 3 to 2. 2 plus 2, 4. 4 plus 2, 6. 2 plus 3, 5. So this is our new available. Okay, let's look at P2. The P2 need is 0 by 2. And our new available is 564. 0 less than 5, 5 less than 6, 2 less than 4. So this also true. When true, we will update available. Okay, we will add the 402, which is allocation P2. So 4 add 2 is 6, 6 add 0 is 6, 5 add 4 is 9. And P3, need P3 is 222. So 2 is less than 9, 2 is less than 6, 2 is less than 6. So which is true also. So we add the allocation P3 110. P3, we want to go back to P0 to see that P0 is smaller than new available or not. So the 6 is less than 10, and 3 is less than 7, 2 is less than 6. So that is true. So we want to add the allocation P0 with 213. This is our final available. We send the total instances, so we get the conclusion. The set sequences, which is P1, P2, P3, and P0. The system is in a set state and therefore deadlock can be avoided. Thank you. This is all for my part.
In question C, suppose now P2 requests additional instances 052. Can it be granted? Step 1, we need to check the request. P2 less than or equal the need. P2 052 less than or equal 052, so it's true. Step 2, we need to check the request. P2 less than or equal the available. P2 052 less than or equal 242, so it's 4. In conclusion, the request 052 from P2 cannot be granted because no resources are available. In question D, based on question C, can you request 030 from P4 be granted? Provide your reason. Step 1, we need to check the request. P3 less than or equal the need. P3 010 less than or equal 222, so it is true. Step 2, we need to check the request. P3 less than or equal available. P3 010 less than or equal 242, so it is true. Banker algorithm, the new allocation P3 is 110 plus 010 equal 120. The new need P3 is 222 minus 010 equal 212. The new available is 242 minus 010 equal 232. In safety algorithm, the need must less than or equal available. P0 632 less than or equal 232 is false. P1 211 less than or equal 232 it is true. If the need less than or equal available, we need to plus new allocation. So we plus 322. The answer is 554. P2 052 less than or equal 554 it is true, so we plus 402. The answer is 956. P3 212 less than or equal 956 is also true, so we plus 120. The answer is 1076. P0 211 less than or equal 1076 is also true, so we plus 213. The answer is 1289. In conclusion, subsequence is P1, P2, P3, P0. The request 010 from P3 can be granted as the system is in the safe state and deadlock can be avoided. Is all our presentation. Thank you.